So hey everyone, welcome back to another video, and today in this video we are going to discuss our second sorting algorithm, that is selection sort. So in this video we will be going to discuss like what is selection sort, algorithm in C++, why it is called as selection sort, time complexity and space complexity. With that we also discuss advantages and disadvantages. So without any further delay, let's get started. But before starting the video, please like, share and subscribe to my channel for keep motivating me for bringing more such content. So let's get started. So first let's discuss like why it is named as selection sort. So let's say we are given this array 3, 4, 5, 1, 2. Okay. Now in this array, what we will say that select smallest element. What is smallest element? 1. Keep it at first position. And the remaining element are 4, 5, 3, 2. Similarly, now remaining are 4, 5, 3, 2. So 1 is at correct position because it is smallest, it should come at first position, right? Now out of these, smallest is 2. Let's keep it at second position. Now remaining are 5, 3, 4. Similarly, smallest is 3. Let's keep it as third position. Remaining are 5, 4. Similarly, smallest is 4. Remaining is 5. So this is selection sort. Selection sort is like we are selecting minimum element out of the array, out of the remaining array, keep it at first position. Now when we are keeping at first position, remaining elements will be considered because first is already at correct position. Similarly, out of this 2 will come here. Now 2 will come, so 3 are like remaining portion for which we need to focus upon. These 2 are their correct position, right? So that's why it is named as selection sort, like we are selecting minimum element and keeping at first, right? So like I think now it's clear like why it is named as selection sort, right? Now what is selection sort actually? Selection sort, as we said, is selecting the minimum element and keeping at first. So it is one of the simpler sorting algorithm. Like you can see we are just taking minimum element, keeping it front, next minimum element, keeping it front. So it is one of the simpler sorting algorithm. It is a comparison based sorting algorithm. So we will discuss like how it is comparison based sorting algorithm. So let's understand the algorithm. So firstly, what we will do, we will maintain two variables, minimum, that is for now let's say 3, and the min index, let's say for now it's 0. Okay. Now what we will do, we will say is minimum is like greater than 4. Like if this element is smaller, no. Let's go ahead. Is 5 is smaller? No. Let's go ahead. Is 1 is smaller than 3? Yes. So we will say okay. 1 is smaller than 3. Let's make the minimum as 1 and minimum index as, since it is 0, 1, 2, 3, 4, third index, right? Now when we will come to 2, is 2 is smaller than 1? No. So obviously don't need to change, right? So finally what we got? We got that minimum value is 1 and minimum index is 3, right? So from this we can say that this 1, that is a third index 1, should come at first position. So what we will do? We will swap, right? Like how it happens, like we traverse array. After that we find the what is the minimum and minimum index. Like now after finding the minimum index, let's say minimum index is 1. Now this is 0th position where we want this one. We want this one to at first position because it's the smallest. Now what we will say, swap these two. So what will happen? This will become 3, this will become 1. So final array will look like 1, 4, 5, 3, 2. Now you have observed something? Yes. The observation is 1 is at correct position. So we don't need to focus upon that, right? Now we need to focus upon this part only. Okay. So now what we will say? For now, let's say the minimum is 4 and the minimum index is 1. This is 0, 1, 2, 3, 4. Now we will say is 5, like we will start from here. So we will say like is 4 like smaller? No. Let's go ahead. 5 is smaller? No. 3 is smaller than 4. So we will say let's update it. This will become 3, this will become third index. Like at third index 3 is the minimum. Now we go ahead. Now at 4 we have seen like this is 2. 2 is less than 3. That means we found more smaller element. Let's change this minimum variable. It will become 2. It will become fourth index. So at final what we got? We got that out of this complete array minimum is sec2. That is a fourth index. So what we will do? We want it at first position. This is a 2. Let's swap. So what we will do? This will become 2 and this will become 4. Now when we write this here 1, 2, 5, 3, 4, what we have observed? We observed that this part is now fine because it's at correct position. Now we got 5, 3, 4. Okay. Now again we start. We will say for minimum is 5 and min index is 0, 1, 2, 3, 4. That is 2. So let's rub this above part for now. Right. Now minimum is 5. This is 2. So we will say like 5 is less than 5. No. 3 is less than 5. Yes. Let's mark it as 3. Let's mark it index as 3. 4 is less than 3. No. Like we can see 4 is not less than 3. So obviously we will not change it. Now what we observed? We observed that what is the minimum element out of it? 3 at third index. Where it should be? It should be at second position. Now what we will say? Let's swap. So this will become 3. This will become 5. So we have seen 1, 2, 3, 5, 4. So what we have observed? 1, 2, 3 is fine. Now where we need to focus upon? 5 and 4. Now 5 and 4 will come. So 0, 1, 2, 3, 4. Now for now minimum is 5. Min index is 3. Now when we will traverse 4 is less than 5, we will update this variable. So now since at final what we got, that fourth index 4 is minimum, we will say let's swap because it should be at third position. So we will swap it. So it will become 4, it will become 5. So finally our array is sorted here only because these part is sorted now. Like 1, 2, you can see if we write it here 1, 2, 3, 4, 5. Since single element is left, obviously it should be sorted. It's the last element, right? So from this, what we have observed, in n-1 iterations, we have completed the selection sort. And what we have done actually, we are keeping like first element as a minimum and traversing. Is there any minimum? Is there any minimum index? If yes, swap it from the first position. Why? Because it should be at first position only, right? Similarly, for second element, we will again traverse and we will find second smallest element. Similarly, for third smallest element, like so on. So this is a selection sort. So selection sort is like we are selecting minimum element, keeping at the front. Next minimum element, keeping at the front, like that. Okay. So this was a selection sort. So let's try some logic for that. So here, what we were doing, we were traversing the for loop for I is equals to 0 to n-1. Why n-1? Because n-1 iterations are more than enough for completing the sorting. Now what we are doing in every iteration, we are doing like we are finding the minimum element. Firstly, we are considering minimum element as first element only. Like at 0th index, we are considering 0th element. At 1th index, we are considering 1th element. At 2th index, we are considering 2th element. 3th index, 3th element, like that. Okay. So every time we will consider minimum value and minimum index as I. And now what we will do? So we will start the for loop and we will go for I is to n-1, right? Now what we are doing? We will say like if any time array of j is less than or equal to, you can say minimum. So like equal to is fine. If you want, you can keep equal to as well. Doesn't matter. So if it is, then we will say that minimum is equal to array of j and min index is equal to j, right? And at the end, this bracket should be at last. And at the end, after completing these iterations, we will say at the end, whatever minimum index you got, swap this minimum index with what? Array of I. That is whichever element you are starting with. For example, you are starting with 0th element and you are finding smaller element, let's say here. So we'll say swap these two, like 0th, that is I, and whatever minimum index, swap array to array minimum index, right? So this is the logic. So let's code it up on the editor. So jumping to the editor, now what we are doing, we will consider array.size. Now since we want to do the n-1 iterations, so we will say n-1, and we will consider minimum index as I and minimum value as array of I. Now we will run a for loop from I to n-1, or you can say less than n j plus plus. Now if any time if array of j is less than minimum, then that means it is a minimum element. Also minimum index is j, and after completing it we will do array of j comma array of minimum index, right? Array of I, like first element and minimum index element, right? So let's try to compile and run the code and check whether it's working fine. Yes, so let's submit the code. So yes, it's totally working fine. Now let's jump to the time complexity and space complexity. So what is the time complexity? We are running two nested loops, right? So this is big of n square, like one nested loop here and second nested loop here. What is the space complexity? Big of 1. Why? Because we are considering only some elements only, which is just big of 1 space only. We are not considering any extra array, right? So now let's jump to the advantages and disadvantages of selection sort. Advantages is easy to understand, implement. We have seen requires only big of 1 memory space. That's good thing. Less number of swap. Why less number of swap? If you observed in the bubble sort, we are just swapping at every point. Like we are just, if array j is greater, just swap, greater, smaller, swap. But in this, what we are doing, we are just completing the iteration and at the last we are just swapping. So this has less number of swap, like only you can say n-1 swaps, right? So that is the thing. So what are the disadvantages? It is time complexity big of n square, which is slower as compared to quick sort or merge sort. Yeah. So quick sort and merge sort, they gives a big of n log n. So it is slower actually. Now it is also not stable, like does not maintain the relative order of elements. Like what it is, let's understand. Like if you see, for example, we have 3 2 4 2 5, right? Now in this, let's say we say that minimum value is 3 and minimum index is 0, right? Now what we will say is 2 is less than 3. Yes, so we will say update it 2 and this will become 1. Now we will say 4 is less than 2. No. Is 2 is less than equal to 2? Yes. So we can say let's swap, right? So this will, like, let's update the variable, not swap, it's let's update the variable. So 2 and 3. Now at the end we got the 5, so we will say it's greater than 1. Now what we will do, we have seen like we are at this index and we are at this index, so we will swap these two index. So this will become 2 and this will become 3. You have observed something, 2 has came at first position. Now remaining position has 2 also, again 2. So what you have observed, that this was the first 2 and this was the second 2. But now this 2 is at first position and this 2 is at second position. Like initially it was first, initially it was second. After initially it was second. Now later on this has came at first position and this become the second. So you can see relative order of elements has changed now. First become second, second become first. That's why it is not stable. So this was about selection sort. I hope you got this algorithm. So if you like the video, please like, share and subscribe to my channel for keep motivating me for bringing more such content. Thank you and have a nice day.